Today's lesson is on trigonometric equations, and this is going to be a couple of day type of lesson. So we're going to start off with some notes here, and then we're going to solve some equations. So a trigonometric equation is an equation that contains a trigonometric expression with a variable such as theta. Okay? Now, blank, such as sine squared plus cosine squared x equals 1, are true for every value of the variable, and that would be identities are all true. And blank are the values that satisfies the equation. So these would be angles. So the angles are the values that satisfy the equation. So on example 1, we're going to solve each equation on the interval from 0 to 2 pi. So this is one time around the circle. So everything we've talked about so far is in play when it comes to trigonometry. So the first thing we're going to do is say, all right, how do we solve this? Well, how do you undo cosine? Well, you take the inverse cosine of both sides. So when is cosine negative radical 2 over 2? So if I look and say, okay, cosine is negative radical 2 over 2 here, there, and there. So 135 there and negative 135 there. But we're doing it, all the answers will be in radians, by the way. So that would be 3 pi over 4, but it also could be 5 pi over 4, correct? Because we could have two answers here because we have two ways to, if I take the cosine of 3 pi over 4, I get negative rad 2 over 2. If I take the cosine of 5 pi over 4, I get negative radical 2 over 2. But you're saying, now hold the boat here. You said when we do inverse cosine, the only answers are from 0 to pi, because that's the limitations put on it. But we're looking at an interval for answers right here. So theta can be anywhere from 0 to 2 pi. So 5 pi over 4 will work as well. So similarly, to undo sine, we're going to do the inverse sine. So the inverse sine of sine is theta. When is sine radical 3 over 2? That's a pi over 3 and 2 pi over 3. And again, 2 pi over 3 is outside the range of inverse sine, but in this case, it's okay because we're looking for these answers. So if I'm going to solve C, I'm going to add 1, then I'm going to divide by 2, and then we're going to take the inverse cosine of both sides. I don't care if you write it like this or like these. Doesn't matter. We know we're taking the inverse cosine of both sides. When is cosine a half? Pi over 3 and 5 pi over 3, right? And if you have to draw the triangles or get your unit circle out, by all means, have it ready to go. Okay, now that's a simple. Those are simple. Now example 2, solve each equation on the interval 0 to 2 pi by combining like terms. Collecting like terms, not going to be really able to combine them. Okay, so I'm going to get the signs together. So I'm going to add sine and add sine. Well, that's 2 sine theta then plus radical 2 equals 0. So 2 sine theta equals negative radical 2. Divide by 2, sine theta is negative radical 2 over 2. So then I'm going to take the inverse sine of both sides to get theta and ask ourselves, when is sine negative radical 2 over 2? And that happens at 5 pi over 4 and 7 pi over 4. Those answers are between 0 and 2 pi. And you can plug it in and check, and it will work. okay? If I did it right, which I think I did. So the next one, we got to get the cosines together. So I'm going to subtract 14 cosine. You do not have to show this work. You can go right to this if you choose. Let's see, then we'd add 7, correct? Negative 5 plus 7 is 2. Then we would divide by 4 and get a half. And then take the inverse cosine. So when is cosine 1/2? Pi over 3 and 5 pi over 3. Okie doke. Now the square root method. All right, now all of these are just things we've done algebraically in the past. We've just thrown a sine and cosine in there. So the first thing we're going to do on this one is add 1. Then we're going to divide by 4. So it's 1/4. Then we're going to take the square root of both sides. Well, the square root of sine squared is sine. What's the square root of 1/4? Plus or minus 1/2. So now we got to have to ask ourselves, take the inverse sine of it. We have two answers here, 1/2 or negative half. So when is sine 1/2? Well, that's pi over 3 and 5 pi over 3. When is it negative 1/2? No, that's not right. Pi over 6, right? My bad. Pi over 6 and 5 pi over 6, and then negative half at 7 pi over 6 and 11 pi over 6. So we have 4 answers then, because the sign of all of these is either 1/2 or negative 1/2, and that satisfies the equation. So on B, we're going to add 1 and divide by 3. So it's 1/3, and then we're going to take the square root of it. So tangent theta equals the square root of 1, which is 1, over radical 3. Now we don't think of it this way. We think of it as radical 3 over 3, plus or minus, because we put the square root of an equation, so it could be negative as well. So now we ask ourselves, when is tangent radical 3 over 3 or negative radical 3 over 3? And guess what? It's all of these. Just like sine, when sine's 1/2, that's when tangent's radical 3 over 3. So at 30 degrees, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, all of these angles have a sine of 1/2 or negative half, and they have a tangent of radical 3 over 3 or negative radical 3 over 3. Okay, factoring out the GCF. Oh, so we're going to get quadratics too here possibly coming up. Oh, quadratic forms, identities. Look at all this stuff. Okay, so what can you look at letter A and what can you factor out? A sine. So what are you left with? 2 cosine theta minus 1 if I take out a sine. So now I have 2 answers or more. I let the sine of theta equal 0, and I let 2 cosine theta minus 1 equal 0. Well, I can answer this right now. When is sine 0? Well, that's 0 and pi. Now I got to continue to solve this one. Add 1, divide by 2, and then take the inverse cosine. So now when is cosine 1/2? I think it's pi over 3 and 5 pi over 3. So there's our answers. Now technically, we should list them like this in order as we go around the circle. This is what I would like you to do, which I should have done on all of these. Okay, let's see. I think they're all in order too. So you use the squiggle brackets to answer these, because that's set notation. That's the set of answers, okay? Now the next one, we can factor out a cosine, and we're left with tangent theta minus radical 3 equals 0. So again, we're going to set each of those equal to 0, and then we're going to solve each of them independently. Well, we take the inverse cosine. When is cosine 0? Pi over 2 and 3 pi over 2. Tangent theta equals radical 3. Take the inverse tangent of both sides. When is tangent radical 3? That's got to be positive. I think it's pi over 3 and 4 pi over 3 down in the third quadrant. It's positive. So theta is going to equal, in order, pi over 3, pi over 2, 4 pi over 3, and 3 pi over 2. If you go around your unit circle, you will see that those are the values that work in this equation. Now, quadratic form. So again, we're looking from 0 to 2 pi, all the possible answers. Now it says solve each equation quadratic form. Okay, let's see. Well, I see cotangent on both sides. So let's divide that out. So now we have cosine squared theta equals 2. So I would just take the square root of both sides. So now we have cosine theta equals plus or minus radical 2. Let's see, do we do something wrong here? Oh, we don't want to do that. Doesn't work. Doesn't work. My bad. We can't lose the cotangent. So what we're going to do is we're going to put the cotangent on the left side. We can't do that with equations. It just doesn't work. So then let's factor out a cotangent, and we're left with cosine squared theta minus 2 equals 0, right? So then we do this and go cotangent theta equals 0, and cosine squared theta minus 2 equals 0. And we're back to that. That doesn't work, does it? When is cosine 2? Let's see. This is not a good problem. We get 2. So cosine theta equals plus or minus radical 2. But our cosine is never radical 2. So when we take the inverse cosine, we'd have to use our calculator. I don't like this method either. So let's see if we can clean this up a little bit. Let's see. I think that's, honestly, I think that's the only way to do it. We're going to skip that one. Let's look at B. Okay, now on B, we have sine and sine. I like that. So what we're going to do then is we're going to look at this problem in this manner, okay? And if you remember from last year, since A is not 1, now these are quadratics, remember we take A times C and it's got to equal B. So 2 times negative 1 is negative 2, and it's got to add up to negative 1. So what times what gives you negative 2 but adds up to negative 1? Well, that's how we factor it. So what times what? We got to split the middle term. Well, let's see. That would be negative 2 times negative 1 is negative 2. Got to add up to negative 1. So that'd be 2x squared minus 2x plus 1x minus 1 equals 0. Correct? Think about it. Now, all I'm going to do with the x's is replace the sign here in a second. So if I take out, let's see, I can take out 2x here, and I'm left with x minus 1. But I have to have x minus 1 on the other side, split in the middle term. And you may have done this differently, but I'm showing you a way that's really easy. Negative 1 divided by negative 1 is plus 1. So our factors are 2x plus 1 and x minus 1 equals 0. Now, how's that help? Well, change the x to sine. And we have our equation. Now it's two equations now. It's 2 sine theta plus 1 equals 0, and sine theta minus 1 equals 0. So sine theta equals 1. Take the inverse sine. When is sine 1? Oh, let's see. When is sine 1? Pi over 2. That's it, isn't it? Okay, this one, sine theta equals negative 1/2. Subtract 1 divided by 2. Take the inverse sine. When is sine negative 1/2? 7 pi over 6 and 11 pi over 6. So your answers then, I'm running out of room, are pi over 2, 7 pi over 6, and 11 pi over 6. Whew, that's some heady stuff there. Now, you do not have to convert it to x's. You could have done the same thing with theta, or sine theta, if that would have been easier for you. But a lot of people like just putting x there before we factor. Okay, so similarly, you can do the same thing on c. Again, a is not 1, a is 6. So if we're going to split the middle term, a times c got to add up to b. B's negative 1 here. A times c is 6 times negative 2, which is negative 12. So I need a number, two numbers. When you multiply them, you get negative 12, but they're going to add up to negative 1. Well, that's negative 4 and positive 3. So I'll just leave the cosine here with this problem this time. So we're going to split the middle term. So we're going to take negative cosine and make it negative 4 cosine plus 3 cosine. How does that help? Oh, not very good on this one, but this will work. So split those two up. What can we take out of the first one? A 2 cosine, right? What's left? 3 cosine minus 2. So we have to take a 3 cosine minus 2 out of this side. And then we look at the last terms and divide them. Negative 2 divided by negative 2 is positive 1. So your factors are 3 cosine minus 2 and 2 cosine theta plus 1 equals 0. So there's your factors. Set them equal to 0 and solve. I'm going to take the one on the right first. That's negative 1/2, isn't it? Inverse cosine of that. Oops, inverse cosine. That's going to be, when is cosine negative 1/2? Negative 1/2 for cosine. 2 pi over 3 and 4 pi over 3. Yep, and when is, let's see, we got to finish this one. Cosine theta equals 2/3. Say what? And then we take the inverse cosine. 2/3, huh? Okay, now take your calculator. This is where it gets dicey. Inverse cosine of 2/3. Make sure you're in radians. Make sure we're in radians. Gotta change my mode. I got 0.841. You usually go 4 decimal places. So theta equals 0.8411. Okay, now we have to think to ourselves. Cosine is 2/3, so it's positive, so x is positive. So if you can think about a unit circle here, and we're going up, right? 0.8411 is about right there. Now that's 2/3 then. 2/3 is right here. Then this angle is also part of the equation. So I'm going to have to go all the way to here. Well, this little spot right here is negative 0.8411. So to get this in the positive direction, so we make sure we're between 0 and 2 pi, we need to take 2 pi minus our answer. And that's 5.4421. So then our total answer is 0.8411 and 5.4421. Now, I wouldn't worry about the order on these. So there's two approximate answers and there's two exact answers. And we found all of them. Now, you can see why it's going to take us a few days to go through all this. Okay, now on D. D has a cube in it. And whenever you have four terms, we should always factor by grouping. So we're going to take out a cosecant squared. What's left? Cosecant theta minus 1. So that's what we're going to be left with here. And then we're going to take 1 divided by negative 1 and get minus 1. That equals 0. So it's cosecant squared theta minus 1 times cosecant theta minus 1 equals 0. So we're going to split those up. So cosecant squared theta would equal 1, and cosecant theta equals 1, square root. Cosecant theta would equal plus or minus 1, and this one, so it's redundant. It's the same thing. Cosecant theta equals 1. So now all we got to ask ourselves is, when is cosecant negative 1 and positive 1? Okay, so cosecant is a reciprocal of sine. Well, the reciprocal of 1 is 1. So we can just ask ourselves, when is sine 1? And when is sine negative 1? 3 pi over 2. There's our answers. Now, this is not easy, guys. Not easy at all. And if I go back to this one on A, we can find it by using, I apologize, we can use it by using decimals. I forgot we could do approximations. Now the last ones use identities. Okay, and by that it means we don't want to play around with multiple trig functions. We have 2 sine squared theta equals 3 minus 3 cosine theta. So it looks here, I have a sine squared and a cosine. Well, there's no way to convert cosine to sine. But there is a way to convert sine squared to cosine. Sine squared would be 1 minus cosine squared. So now we can get everything together. First, I need to distribute. Right? Okay, now we don't want a negative cosine, so we're going to add 2 cosine squared minus 3 cosine, and then we're going to subtract 2 and get plus 1. So we have 2 cosine squared minus 3 cosine plus 1. Just subtracted 2, added 2 cosine squared, and got this. Okay, now, again, we have to split the middle term. I'm running out of room here. A times C has to add up to B. So that's 2 has to add up to negative 3. So what times what gives you 2, but when you take those two numbers and you make it adds up to negative 3, well, that's pretty easy. It's minus 2 cosine theta minus 1 cosine theta. And then we factor by grouping. So we take out a 2 cosine. What's left? Cosine minus 1. Cosine theta minus 1 over here automatically. You rewrite it. 1 divided by negative 1 is negative 1. So your factors are 2 cosine theta minus 1 times cosine theta minus 1. Now I'm running out of room, but I'm going to set this one equal to 0 and this one equal to 0 and solve. So cosine theta equals 1/2, cosine theta equals 1. When is cosine 1? 0. When is cosine 1/2? Pi over 3 and 5 pi over 3, correct? So theta would equal 0, pi over 3, and 5 pi over 3. The factoring by grouping is going to be interesting. Letter B, I'm running out of room, but letter B is sine 2 theta equals 2 sine theta. But what's sine 2 theta? Look it up in your identities. It's a double angle formula. It's 2 sine theta cosine theta. So look at that. So if I replace sine 2 theta with 2 sine theta cosine theta and divide out 2 sine theta, you get cosine theta equals 1. So theta would equal 0. That's the only answer it could be. Right? It's the only time cosine's 1. Okay? So that was an easy one. Now let's see if we can do this last one. Okay, cosine 2 theta plus cosine equals 0. Now this one, cosine 2 theta has 3 possibilities, but it really doesn't, because the key here, it's got another cosine. So you want to use the one that says 2 cosine squared theta minus 1. And looky there, because then we have a quadratic that we can solve. And we have to split the middle term again. Now, when I say have to split the middle term, you don't have to. I'm going to show you how I would do it. I know the only factor of 2 cosine is 2 cosine and cosine. That's the only way to get 2 cosine squared. I also know that the only way to get 1 is 1 times 1. So your first and your last have to be those. Now you got to figure out what goes in the middle. So what I do is I just take your outers times your inners, or outers and your inners, and see what I have 2 cosine on the outer. I have 1 cosine on the inner if I multiply them. I'm foiling in my head. Well, I need a plus cosine. So that means that has to be a minus, and that has to be a plus when I check my outers and inners. Outers is 2 cosine, inners minus 1 cosine gives us 1 cosine. So I don't have to go through that stuff if I don't want to. So I'm going to split them. So cosine theta equals a half. Oh, I already got this one. When is theta negative 1? Or when is cosine negative 1? Pi. When is cosine 1/2? Man, we're getting a lot of these, aren't we? Pi over 3 and 5 pi over 3. We're going to get these memorized. So theta equals pi over 3, pi, and 5 pi over 3. Okay, so we're going to take a few days and talk about trigonometric equations.